Hello everyone, I hope you are doing well. My name is Kishan Surani. Now I would like to give quick introduction about our project title and our group members. So our group project title is using KUNDUR system for the connecting of a large renewable power station with battery storage to the Australian national grid. In my group, we are 3 members. As I said, my name is Kishan Surani. The second one is Vivek Akanapalli and the third one Jaideep Punjabi. So let's begin with the first slide. In the year 1982, first PV with battery storage system established in the California, USA. The aim of our project is to investigate the 350 megawatt photovoltaic farm with 550 megawatt battery storage system in PSSE software by using KUNDUR system. So next slide, please. So what is the KUNDUR system? The KUNDUR system is basically a test case which is used for studies on a dynamic stability, power interchange, oscillation damping, and many more. So as you can see in the block diagram that it contains 11 buses, 4 generator with 2 areas, and these 2 areas are connected with line. And 2 loads are supplied to the system at bus 7 and 9. 2 shunt capacitors are also connected to the bus 7 and 9 as shown in the figure. So let's move into the next slide. This diagram shows that when the generation of energy is higher than the load requirement, then this energy should be stored in the battery bank. However, when the generation is less than the load, then battery bank feed energy to the grid and fulfill the requirement of the load. Next slide, please. Now the size of the battery, the 350 megawatt photovoltaic farm has a 500 megawatt capacity of battery storage system. So if we consider one unit stored 12 megawatt, so we require 42 units to store the whole generator energy power, which is 500 megawatt. Next slide, please. There are various forms of storage system. Out of all the system, we selected battery storage system because of it has more advantages than other system, such as high efficiency, and it also removes the reactive power by changing the frequency and voltage. Now I hand over to my teammates Jaideep Punjabi. He will explain further presentation. Thank you.
Thank you, Kishan, for inviting me. Here I am going to talk about my section of the methodology, which consists firstly our main aim. We fulfill our aim by using a software named Power System Simulation for Engineers, and we use a PSSE software, Power System Simulator for Engineers, and we investigate the construction of 350 megawatt power bank with battery storage. For that, we use a Queensland and New South Wales system in a given model and parameter that we used, and then we solve the load flow solution, and we also investigate about the transmission line parameters, and finally we choose the 275 kilowatt high voltage transmission line because of the I2R losses. By reducing the I2R losses, by increasing the voltage, and we also increase the efficiency of that bus. And then finally we connect the PV bus at the bus number 408 at the Queensland North, and by connecting that bus, we all see that the effect at the bus number at 202 and 408. So by giving a load flow solution, and by finally we inject the shunt inductor and provide a VAR voltages, and we maintain the voltage at the range of the 0.95 to 1.05. Then we also follow the rules of the NER rule, National Electricity Rules, and the first rule is a S5.2.5.1 is a reactive power capability, and we all see that at the bus number 203 name is a MPS Gen, is a MPS Gen is a not in a plus or minus 39.5 range. So by using the formula of Q is equal to V square B, we reduce the voltage from 1.05 to 0.97, and by maintaining that way. The next is the rate of change of frequency. So we perform the simulation in a PSSE without PV and by using a PV connection. So in a PV connection, the rate of change of frequency is high, and so for that we use a governor, and the main of EMA governance is to maintain the synchronous speed. By maintaining a synchronous speed, we maintain the frequency. And the next we move to the critical clearing time. Critical clearing time is a very important for our project, because by knowing the critical clearing time, which is the graph between the angle and time. So by finding the critical clearing time, we find the protection system. So we all see that the without PV is a very good, but in a with PV it's a long, it's a not proper waveform. And last one is exciter tuning. So by using the settling time of 2.3 second, we use the better damping and fulfill the minimum requirement of Australian energy market operation. And now I would like to invite Vivek Akannapalli and hand over with him to the harmonics.
Hi everyone. As my teammate JDP explained about the process of using PSSC in the software, you need to do some further calculations as well to maintain the system stability. We need to perform this harmonic calculation operation. So we have two different set of formulas for that. EH and EH. We have two different formulas and we have an alpha term in the second formula. Can you go to the next slide? The table column shows there are several different types of harmonics and each has a several different planning level and allowable level. You need to calculate each and every voltage level for the harmonics from starting from second to 20th harmonics, and we need to find the value. It's an generating value, and later we need to take the alpha value from the table as shown here, and we need to calculate the voltage value as well. You need to compare both the equations. You need to find if the generation is greater than the nominal load, then the system is ready to go and it satisfies all the conditions. On the other hand, the system does not work if the load is less than the generation load. Next slide, please. And the next part is calculating the flicker. To calculate the flicker, we have the two different set of formulas. One is the short flicker and one is a longer flicker. So it happens for every 30 minutes of time period on an average. When a short time flicker occurs, it happens up to 10 minutes, and when a long term flicker occurs, it lasts up to 2 hours. But the most effective one is the short term flicker because we can reduce these times of flickers by using the by calculating the negative sequence current. And next slide, please. And two different protection methods we have: over voltage protection and under voltage protection. Over voltage protection is caused by due to lightning surges, direct lighting on the main stream line, or voltage surges in between the lines. So to undergo and changes and to protect the system from this is to install lighting arrestor at the generation stations, and to protect the system from underload voltage. It depends on the weather forecast conditions. You need to check the weather before you are installing your PVs in a particular place, and due to some faults in the transmission lines, the under voltage may occur. By using several different kinds of cables, we can reduce this under voltage as well. The next slide, please. And the conclusion: the overall project says about installing a renewable energy system in the mainstream by using when it is the peak load and off peak load. When it is a peak load, we use a PV system to satisfy the requirement of the customers, and when it is off peak load, we turn off the PV system and use the power generation to charge the batteries in the which we have installed in the mainstream system. The whole idea of the project is to develop an efficiency and to meet the requirement of the customer load. Next slide, please. This is the Gantt chart. Is a planning of a project from the day one till till date. Next slide. Next slide. These are references which I have taken to complete our project. And there are two different recommendations which I would tell you. One is bi-directional flow capability because there are two generation systems, and the second one is increasing the efficiency, quality of and security maintenance of the system to meet the load demand for the customers. Thank you.